All right, so in looking at our graph on the calculator, these are really tiny increments. We need to find a way to see a better, more close-up value, set of values. So if we push Control T and then you push Menu. So I pushed Control T, I brought up my table because the values are jumping in such giant increments, they don't help me. If I push Menu, it brings up these two options, Actions or Table. I need to work on my table. My table is not helping me the way I need it to. So push Enter on number 2, and I am going to edit my table settings so that I can see more information. And what I need to have happen, if you push arrow down, I need to adjust the step that I'm going to use on my graphing calculator on my table. And it's looking like my graph on my paper has 10 increments. So let's see if going at 0.1, because there's 10 dimes in a dollar, so 0.1, let's see if that will help us to get a better idea of what is going on in our graph. So push Enter, and now the numbers are much more visible as to how things change. If you arrow down, we see that we go from a height of 2.04 feet to a height of -1 foot very nicely. So that's really helpful to us. It helps us to get a better understanding of what is going on. So let's go label our graph according to this information, knowing that we start at a height of 15 feet. Okay, so let's see. We will have here on our graph 0, 0.1, 0.2, 0.3, 0.4, and if you're worried about space, we can do 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. So now we're going to do measurements up the y-axis. I only have 10 units up the y-axis, so let's go by twos, and that will work well for us. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. All right. So now that I have values that are on my paper that coincide nicely with what we built for the table on our graphing calculator, let's go plot those points so that we can actually see them. All right, so our table starts on the calculator with a height of 0, 15. So that's right in between, oops, don't go to sleep, 14 and 16. We'll move over 1 unit on the graph paper, and we'll go up to 14.84. So that's almost the same height as what we had on our first point. We'll move over a unit, and now we're at 14.36. So that's just above 14. We'll move over another unit to 13.5. So you need to be careful here as you're graphing. 13 is smack in the middle. And so 13.5 looks like it's really close to 14, but it's not because of the scale on our paper. We move over another unit, and I'm at 12.44, so that's about 12.5 units. Again, being mindful of our scale. Now we have a nice clean coordinate point of 0.5 and 11. So 11 will be here, perfectly centered on our paper. We'll move down our graph on our calculator, and we see that our height begins dropping quickly. I'm at a distance of 0.6 with a height of 0.925. So almost just here in the middle, like 0.9. Move over a unit to 7.16. So here's 0.7, and 7.16 is just about here in the middle. It's really dropping in height at this point. At 0.8, I'm only up 4 3/4. So here's 0.8, go up 2, there's 4, and not quite up to 5. Move on my graphing calculator. I'm at 0.9 and 2.04, so it's almost perfectly on the height of 2. And then at 1, I've dropped below the water surface. So I'm actually down here where my decimal point is on the 1. So that gives me a nice visual curve for the graph that we needed to draw right through there. So we have done our first assignment in this problem is to graph the function. We're asked how many seconds does it take for the sinker to hit the water. So the sinker hits the water right here as we are at a 0. This is the water height. This is where the sinker hits the water. So this is very much equivalent to an x-intercept, or a 0, or a root, or a solution. So that's what we're going to find using our graphing calculator in just a moment. Let's write it on our paper. Sinker is going to hit the water at the same location as an x-intercept, a root, a solution, or a 0. So let's go back to our graphing calculator. Push Control T again, and your table goes away. Now, it's really tricky at this point to see where exactly that happens on our graphing calculator. So we're going to very carefully use our menu to analyze the graph. And we're going to find a 0. So my hand is all the way over on the left. That's no good. Let's bring the hand and the blinking all the way to the right. So it's to the right of my curve. I just need it somewhere over there to the right of my curve. Push Enter, and then slide it in, and a coordinate point shows up. I hope you can see that on the screen. All right, so we find that we have a 0. We have our x-intercept at almost 1, and we can now write that down onto our paper. So that is the coordinate point of 0.968, 0. So after this is going to happen, our sinker is going to hit the water at 0.968 seconds. Great. So now we've answered the second question for this assigned problem, and finally use inequalities to describe a reasonable domain and range, and we'll have it finished. So the domain, if you remember from our discussion on linear functions, the domain is always the x values used. And in this graph, we have our x's start at a time of 0. That's when you initially cast off your fishing rod. And it hits the water here at this 0.968 seconds. So that's our domain. Those are the x values that were actually used. So let's write that down. 0 really happened, so we have a bar underneath of our less than inequality symbol. The domain uses the x's, and we went all the way over to, and it touched water at 0.968 seconds. That is our domain. It's the x values used. To finish this off, finally, we just need the range. The range is the opposite of the domain, so it's not the x's that are used, it's the y values that are used. So here in our graph, we see that we have a height ranging from 15 feet, dropping all the way to 0 feet when it hits the water. But remember, when we put our information in inequalities, we always start from the lowest and state it to the highest. So we go from the bottom up. For this problem, that means that we hit water with a height of 0. These are the y's used. And we started at 15 feet above the water. Now we have answered all of the questions asked of us in this problem. So you can stop the video and try to do the next problem on your own. And if you get stuck, bring it to me and I'll be happy to check it for you.